question 2.1 says calculate the number of terms in the following arithmetic sequence. So we're given 6, 1, -4, -9, and it continues. And we notice that the last term is -239. So when they ask you to calculate the number of terms, we are concerned with getting the general term and equating it to the last term so that we can solve for n. Because remember, in any number pattern, your last term represents Tn. So if we're able to get Tn, which is the general term, all we have to do is equate it to our last term and solve for n. So let's do that. So here's what we have. We start off by getting the general term. We know for arithmetic, it's in the format Tn is equal to a plus d into n minus 1. Now remember that a represents your first term, which is 6 here. D is the difference. Now, if you look at all of these terms, we notice that they are minusing 5 each time. So D is -5. And that's important. If your difference is negative, include the negative when you're substituting. That would go into n minus 1. So we're going to take that -5 and multiply into the bracket. We get -5n plus 5. Now, simplifying, we have 6 plus 5, which is 11. So 11 minus 5n as Tn. Now what we're going to do is take the last term, which is -239. Since that is represented by Tn, so we substitute and we equate it to 11 minus 5n. Now our aim here is to solve for n. So what I would actually do is take the -5 over to the left to make it positive. I would then take that -239 over to the right to get that positive. It'll be 11 plus 239, which is going to be 250. And then to solve for n, you're going to divide both sides by 5. So we have n is equal to 50. Now here's what this means. This actually means that term 50 is equal to -239. And since -239 is your last term, it means that this number pattern consists of 50 terms. So therefore, if you look at the way the question was asked, right, the number of terms in the following sequence. So we can say, therefore, it has 50 terms in it. So we can conclude by saying there are 50 terms in this arithmetic sequence. So for 2.2, we are given 2m12p, and it continues. And they say are the first 4 terms of a quadratic sequence. If the second difference is 6, calculate the values of m and p. So we're only given 4 terms of the quadratic sequence, and we are given the second difference as 6. But we need to figure out what the values of m and p are. Now let's first start off by writing this down. So here's what we have. We have 2m12 and p, which is the quadratic sequence. Then we know that we can minus these terms from each other to get the first difference, and your first difference is arithmetic. So the first differences were not given to us, so we can actually get that on our own. But we were given the constant second difference, which is 6. Now let's focus on getting the first differences. Normally what we would do is, in our quadratic sequence, we would ask ourselves, what are we adding onto 2 to get m? Then what are we adding onto m to get 12? And what are we adding onto 12 to get p? However, since we have variables, and it always works this way, if you have a quadratic sequence and you have variables in between, you don't work forward as in 2 plus what gives you m. You don't ask yourself that. But instead, you work backwards and you subtract. So let me show you. I'm actually going to start off from the end here with p, and I'll move backwards. So we know that the first difference means subtract, right? So the difference between these values would give you this term. So it would be p minus 12. To get the one before that, it would be 12 minus m. And the term before that would be m minus 2. So here's our first differences, which forms the arithmetic sequence. Now, especially when it comes to solving for variables in your arithmetic sequence or in your quadratic sequence, you can actually work with your arithmetic part here, with your first differences. Because what we know is that the difference between these two terms is 6, and between the next two terms, it's 6 as well. And a general rule is that whenever you are solving for a variable in any number pattern, work as if you're calculating what's constant. And what's constant here is our second difference. So I'm going to work with the arithmetic part, and with arithmetic, how you would normally get this difference is you can choose which two terms. I'm actually going to start off with term 1 and term 2. So here's the thing, right? When we subtract these two terms, it should equal to 6. Just like how in the quadratic part we subtracted m minus 2 and it gave us that first term. Here, if we subtract 12 minus m minus 2, it should equal to 6. So we can simplify by taking that negative into the brackets. So we get negative m plus 2. Then let's gather like terms. M minus m is negative 2m. Now we have 12 plus 2, which is 14. But we're going to take that 14 over to the right-hand side. So it's actually going to subtract to give you negative 8. To solve for m, you can divide both sides by negative 2. So m is equal to 4. Now let's work with the next two terms. So the difference between 12 minus m and p minus 12 is 6. So we would have p minus 12 minus 12 minus m is equal to 6. And here's the thing, we now know what m is. So we can replace m with 4. Now let's take that negative and multiply into the bracket. We get negative 12 plus 4 is equal to 6. We want to get p alone on the left-hand side. And if we gather like terms, we have negative 12 minus 12 is negative 24, plus 4 is negative 20. Taking that 20 over to the right-hand side, it will become positive. We have 6 plus 20, which is 26. So these are your values for m and p. And let's say that you're not sure if this is correct. You can always take these values and substitute into the given pattern. So we can substitute in here, we can substitute values for m and for p, and when we get the difference, it should give us 6. So that should work out, which it actually does here, right? So m is 4 and p is 26 is correct. Now we're on to 2.3. It says consider the geometric series. We've got 2 into 3m minus 1 plus 2 into 3m minus 1 all squared plus 2 into 3m minus 1 all cubed, and it continues like that. So it's actually going on up to infinity here. Now 2.3.1 says, for which values of m will the series converge? So there is a certain condition that we have in geometric series where it converges. And we know that any series where r lies between negative 1 and positive 1, that is a series that will converge. So let's start off by writing down what we have. So here's what we have. And in order for us to figure out the values of m for which the series will converge, we first need to know what r is. So we're going to start off by saying r is equal to, and how we calculate r for geometric series, we use the quotient, so a fraction of any two consecutive terms. So we can say term 2 over term 1 or term 3 over term 2, whichever you prefer. I'll just go with term 2 over term 1. So I've got 2 into 3m minus 1 all squared over 2 into 3m minus 1. So what happens here? The 2's cancel out. One of the brackets from the top cancels out with the bracket at the bottom. So what we're left with is 3m minus 1. That's r. But now, if we go back up to the question, we are concerned with the values of m for which the series will converge. And there is a special condition for a series to converge. And that is, for a series to converge, r must lie between -1 and +1. So since we know that r is 3m minus 1, let's replace r in the middle. So 3m minus 1 must lie between -1 and +1. And all we have to do here is work towards solving for m. So we want to get m alone in the middle. Now the first thing we want to cancel out is this -1. We can cancel out -1 by adding 1 throughout. On the left hand side, -1 plus 1 gives you 0. In the middle, so the 1's cancel out, we're left with 3m. On the right hand side, 1 plus 1 is 2. The last thing we're going to do is divide throughout by 3. Now 0 divided by anything is 0. If we divide the middle by 3, the 3's cancel out. We now have m alone. And on the right hand side, 2 divided by 3, that will just stay as 2 over 3. So these are the values of m. M lies between 0 and 2 over 3. That means that m can be any value between 0 and 2 over 3. As long as we have a value of m within this range, it will allow this given geometric series to converge. Now 2.3.2 says calculate the sum of, well, it's supposed to say the sum to infinity of the series if m is equal to 1 over 2. Now we have a specific value given for m. So for us to get the sum to infinity, we would have to take this value, 1 over 2, substitute into the pattern so that we can get actual values. We can get an actual pattern that we can work with. Let's start off by doing that. So this was the pattern that we were given, and we're now told that m is 1 over 2. So we're going to substitute 1 over 2 wherever we have m. And now we're going to simplify each term so that we can get values as each term. So simplifying, we get 1 as our first term, 1 over 2 as our second term, 1 over 4 as the third term, and it continues like that. Now what we are required to get is the sum to infinity. So remember, sum to infinity, we need to know what a and r is. A is your first term, so a here is 1. What about r? So you can recalculate r if you'd like, or you did actually get r, but in terms of m in the previous question, where it was 3m minus 1. So you can actually substitute the half in there. Or if you're going to calculate it using your new pattern, you can actually do that. I'll take term 2 over term 1. A half divided by 1 is a half. So we have everything that we need to get the sum to infinity. So remember, your formula for sum to infinity is a over 1 minus r. We're going to substitute in here. A is your first term. 1 minus r, r is a half. You can put the whole thing on your calculator. And we get 2 as our answer. Please remember to like, subscribe, and turn on your notifications for more content.